Hey everyone, this video I'm going to show you how to deploy TypeScript code to an AWS Lambda. So right here is our TypeScript code. We can see we've got nice autocomplete. So if I do event dot, we can see everything that's part of the event that comes into our AWS Lambda handler function, which in this case, we're assuming the trigger is API Gateway version 2. I'm going to show you how to bundle this code into JavaScript and deploy it up to a Lambda. So if we look at the code here, we're developing in TypeScript and it's been transpiled down to JavaScript over here. And I'll also show you how to hook this up, of course, with CloudWatch logs. So these are all the CloudWatch logs that are coming through. And I'll also show you how to set a retention of 1 month so these logs don't bloat up and take over all the space. All this code will be available in my Medium, which is linked in the description. Also, if you like content like this, please be sure to like and subscribe and enjoy the video. So let's start with just a completely empty directory. The first thing I'm going to do is just create 3 directories. These are backend for our Lambda code, IAC, or short for infrastructure as code, for our Lambda setup, and then bin, short for binary, for our script files. And now, the first thing we're going to work with is our TypeScript application. And so to quickly get this started, first we're going to run npm init-y to create a npm project. So that will just create a package.json file with just everything set to default. Next, let's install all the libraries that we are going to need for this project. And these are all going to be development libraries. So when we install them, we're just going to tag on a -D at the end. But essentially we're doing it types.lambda -AWS Lambda for handling Lambda types are just basic node types. TSC alias, which we'll see more on why we need this later. TSX, just specifically for development, and then TypeScript to add TypeScript. So let me run this. And after these have all installed, the next thing I want to do is create just some scripts. These are going to be to run our application in watch mode, to just start it regularly, and also to build it, for which will be used in our deployment. And here is where we can see our stuff in action. So TSX is going to be running everything in development. So we can see it's going to watch our index.ts file, which means that any changes will be reflected live. And then here's where TSC alias comes in handy. And so what we're going to do when we build it is we're going to be using TypeScript to create some aliases for us, path aliases specifically, so that we can import things by, say, like it'll be import from @-services-my service, as opposed to, say, doing something like services. So it's a way to clean up our locations, and we're going to be doing that. But the issue is when we transpile this into JavaScript, it will still include the @aliases. So it'll be @-services. And when we deploy that to our AWS Lambda, it won't know where to look to find that stuff, which is what TSC alias will handle for us. And you'll see that in action too. So if that doesn't make complete sense, you'll see it in action soon. But let's start just doing our scripts, or our TypeScript code. And the first one is going to be in our source directory. We're going to have an index.ts file. And this is just going to be the entry point to our AWS Lambda. And I'm just going to paste in the code here. It's going to be very straightforward. So what it is for our types, we're going to be importing API Gateway Proxy Handler version 2, which we can see we assigned to our handler right here. And basically this is just saying that the trigger for our Lambda is going to be API Gateway Proxy Handler version 2. If you were using, say, for example, API Gateway Proxy Handler, I think there's probably just version 1, this one right here, which is basically a difference in the payload, I believe, you would do that. Or if, say, you were doing S, and it was whatever the trigger is what you change this type to be. So say SQS is the trigger, or event bridge, something like that. But here I'm going to be assuming it's API Gateway. Then we can see our imports here. This is how TSC alias will help us that I was speaking about earlier. We can see that in action here. And in here I just showed that adding this types here allows us to get all of this typing information for the event and the context object that are passed through. So we can see all this, and you can double check that those work with this URL right here. So these are basically the formats of the payload. But let's just create these services, and these are really just these 2 services here. These are really just dummy services. These are just dummy services. They're just to show you how the imports work. But I'm gonna have say goodbye for goodbye service, and then hello service is just going to do say hello. And then when we import them in here, so it should find these now, might need to, or actually we don't have, the reason it's not finding them at the moment is because we don't have a tsconfig.json set up. So let's do that next. So now at the top level, we're going to do tsconfig.json. And so all this code, once again, will be available on my Medium. So to paste all that, just go there. But I'm just going to paste in some modern compiler options. This is how we configure our TypeScript compiler. And the important ones are we're going to be compiling to common.js. So we're going to be using require module exports as opposed to import and export. And then here are our paths. So our base URL is going to be our source folder. And then our services, we are setting @services means services and then everything in there. And of course it prepends the base URL here. So this is technically -source, -services is what this will be. And then we don't have say hello here. So we get our nice typings. We have say goodbye. But that's everything here essentially. So that's all it takes to get this up and running. So let's just actually try out these scripts now. So if we do npm start, we get logged out, how are you doing today, which comes from this here. Let's do npm run dev. Let's see that the watching is working by just type some stuff here, save, and it gets a live update here. Awesome. So we can see that's working. And then one more npm run build, do npm run build, outputs our dist folder, and look here notice how the require here, instead of using that our alias, we're just doing .-services -hello service. And this is important because if we didn't use tsc alias right here, then this would remain as, what was it? Like @services dash, and it wouldn't be able, the AWS Lambda would not be able to find where that is. But that's all we need to do in here. So now we can start working on our Terraform stuff. And the first thing I'm going to do is I'm going to create a lambda.tf file. And I'm going to paste in all of this code and I'll go over it line by line. It's there's not too much in here, so it shouldn't be too bad. But first thing I'm going to do is this just creates our Lambda function, which we're going to call my TypeScript Lambda. We specify the location of the zip file, which will be the code that we use. Index.handler essentially means this is the file name and this is the function name, which is why the file is called index.js. And the handler is this export. So that needs to match up with what we have in here. Our runtime is going to be Node.js version 22. And then we're also going to give a role to our Lambda. And this role will allow it to basically access or write logs to CloudWatch. And speaking of CloudWatch, that's the next resource we have right here, which is our log group. And we're going to set a retention of that to 30 days. Because if we don't explicitly set a retention right here, it will be indefinite, which means it'll just store logs forever, which can increase your costs as time goes on. If this is a very sensitive Lambda, like say handles payments, it might be a good idea to have it just store logs forever. But for this demonstration, I'm just going to set it to 30. And now we're going to create the role that our Lambda is going to assume. And so what we do is create a role that only Lambdas can assume. So the statement is allow, and the identifier is lambda aws.com, which is lambdas. So we're saying for Lambdas, allow them to assume this role. And a role, just think of it as like a hat you put on that gives you certain tasks. These tasks are actually assigned through policies, which is what we do down here. And the policy that we want to be able to assume is this one here, which is basic execution role. So you attach policies to a role, and then you attach the role to a service, principal, and right here it's our service, which is our Lambda. And we call it Lambda logging because AWS Lambda basic execution essentially allows it to just do basic CloudWatch logging. Next, the next file we're going to create inside here is going to be called providers.tf, which is going to be our Terraform providers. And there's not going to be much in here. The only provider we're using is AWS. So I'm going to specify in here providers AWS, specifically version 6.0 or greater, and then Terraform version 1.5.0 or greater. I think I'm using like 1.10, so this is just kind of pulled out of nowhere, but that's just what I'm going to specify here. And then let's create our variables. So that's where this error is coming from. So if I do variables.tf and I paste in these here, so our region is going to be EUS2, which is London. Profile is going to be Terraform. Make sure this profile matches up to the profile that you have inside the folder .aws-credentials, which is, so it'll use the secret token access key for this profile. So this should be specific to you. I created a profile called Terraform that allows me to do all this infrastructure handling, which is why I'm using that. And then finally, let's create another file, which is going to be called output.tf. And this is just going to contain our outputs. The one we're going to have is just our Lambda name, which we're going to use in our deployment script. And we're going to use that, create that deployment script right now. So this is just going to be a simple script that will essentially spin up our infrastructure, build our code, and then deploy it. So nothing crazy here. Once again, find the code on my Medium, but it's pretty straightforward. So we have this essentially says if anything goes wrong while running this, just exit out. These are going to be some directories. So the script directory, which is the bin directory, our root directory of the project, where our backend code is, where our dist file is, zip path, stuff like that. But you can see what we do here is we build our Terraform by initializing Terraform, and then applying and specifying auto approve, so we don't have to say approve. For a more production level, I wouldn't recommend doing something like this. You should probably want to review what's going on, but this is simply for demonstration purposes. This is where we get our Lambda name from the Terraform outputs. Then we do our build stuff right here, or build our TypeScript code. And so what this does right here is it installs the exact versions from package.json. So npm CI, that's why we're doing that. So we get exact lockdown versions. Then we build our TypeScript project, and then we prune it for production, which basically means remove all dev dependencies, which is essentially the only dependencies that we're using in this. But that'll make everything smaller, which is just more efficient. Then we actually create our zip package. So we remove it if it's already there, and then we zip it up. And then we deploy our Lambda code. And first we check if the function exists. And if it does, that's when we update the code with our zip file. And if it doesn't, we're going to say error, it doesn't exist. And then we'll just do a nice little message of it deployed successfully. And that's all we need to do there. But next, let's go in here and we need to make this executable, which we can do with +x. So deploy.sh. So now we should be able to run this. So if I do, and actually before I run this, I think I already have a Lambda called my TypeScript Lambda. So I'm going to do my TypeScript Lambda 2 because I already have one of these. But I'm going to do, if you run .deploy, let's see what happens. So it looks like right now we're installing our plugins, which is good. So Terraform's been initialized with the plugins. Let's see what happens next. Now we see we have 4 things to add. And what I get is the role already exists. Like I said, because I've already made this example. So let me just change the name of this role. I'll just call this role 2. And let me run the deploy again. Now we get 4 to add. Everything's been created. And actually what we get is there's no zip file or directory. And this is kind of a chicken or egg first problem. And for this demonstration, I'm just going to fix this by I'm just going to make a file called lambda.zip. And this is just going to be a placeholder. It'll end up being replaced. But essentially, when this Terraform code is running, it's looking for this. And we don't have one currently. In our deploy script, this starts to run after we've done all the building, which is why it's not working. So I'm just going to create a dummy file right here, which then if we run this, it should use this dummy file, and then it will get overwritten here when we actually update the function code. And there seems to be an issue with the Lambda zip file. So what I'm going to do is navigate into our dist folder, and then I'm just going to run zip-r, call it lambda.zip, the current directory. And then I'm just going to take this file and move it up here. And now let's just try and run our deployment again. And there we go. It looks like it worked this time. So it was because our zip file was just an invalid zip file, didn't have an index.handler and all that stuff. But here we go. So now it's deploying it and everything's up. So Lambda deployed successfully. And so now if we go into the AWS console now and just look at our functions, we can see one right here. So this is the one we created 4 minutes ago, my TypeScript Lambda 2. We don't have a trigger because we don't have it connected to anything, but if we look at the code, this should look familiar in here. So we have our index.js file with all our services listed in here. So we can see all this stuff looks pretty good. And the next thing we need to do is just check that let's just do a quick test. So I'm going to test, just run this. Looks like it succeeded. We get back right here. Hello, my amazing Lambda of Destiny. How are you doing? And then if we look inside, let's just check, not our configuration, but monitor, make sure everything worked in CloudWatch. So if we click over in here, here is our log stream, which is this right here. We can see our logs are coming in successfully. And also if we look at our log groups, this is my TypeScript Lambda 2, and we go over the retention is 1 month. So this means after 1 month, these logs will be deleted. But yep, that's all I wanted to show you. I want to thank you for liking and subscribing. Check out my software and courses in the description. Take it easy.